Okay, Chapter 3, Section 1, and Chapter 3, Section 2, identifying pairs and lines and angles, and then Chapter 3.2 is postulates, theorems where they're within. Alright, so definition heavy sections. The first one they talk about are parallel lines, and the symbol for parallel lines is this, so I'll use that a lot instead of writing parallel. And the definition that they give is two lines are parallel if they don't intersect and they're coplanar. So parallel lines do not intersect. And also they are coplanar. So an example, they have a plane here. We have plane T, then we have line N and line M. They are coplanar because they're within the same plane, and they're never going to intersect. So these guys are parallel, don't intersect, and are coplanar. Then we have this other plane here. I'm going to get rid of that. Then we have something called skew lines. And skew lines are lines that don't intersect. And that are not coplanar. So remember, for something to be coplanar, you have to have three non-collinear points. So here's our plane here. We have this other plane. Underneath here. They're not touching each other. We have a line in the first plane on top. Where we go in this direction. No. Where we go in this direction. Then we have another line coming from this plane going out, coming through here. We transpose this line is going to keep going in this direction. They're never going to touch. This guy is going to go up. This way. So these guys are never going to touch. However, they're not coplanar because you need three non-collinear points. In this case, that they share for something to be coplanar. In this case, they don't share any. So these are not coplanar. So these are skew lines. We also have parallel planes. These two planes are parallel planes, and parallel planes are planes that don't intersect. Planes that don't intersect. Okay. And so to recap, here's a picture of it. We have these two lines here. They are coplanar, right? There's three non-collinear points in here that they would share. We have parallel planes T and U. we have this line K such that it goes through both T and U only through that one point. If you look at line M is skew because that line is not going to touch line K, but they're not also going in the same direction, so they're not parallel. And then, but line N is intersecting point K. So M and K are skewed. M and N are parallel. Plane T and plane U are also parallel. Okay, here's some examples of this. We have this box cube. Actually, let's go to another one. Alright, more definitions. Actually, yeah, let's go back to the cube. Alright, so we have this cube. We have AHHG. So here's AH. Here is HG. Right? These guys all parallel to CD. Here is CD. Here is AB, which is parallel. HG right here, which is parallel, and EF down here, which is parallel. They're all, so EF is coplanar with DC, that makes them parallel. CD is coplanar with AB, which makes them parallel. And if we had that slanted in between plane, we could say DC is coplanar with HG. So this fits. And they want to find out the line containing point A. So that would be AB. So it would be CD and AB. And it says skew lines to CD containing point A. So here's CD. AH is skew. BG is skew. FG, but they want containing point A. So here's AH. Here's AG. These guys are both skew. AG is going in this direction, AH is going in that direction, and never shall the twain will meet. They want lines perpendicular CD containing point A. So we have AD, which is definitely perpendicular, BC, EF, and FC. But the only one that has point A is AD. Planes parallel to EFG. EFG. Right here, the plane parallel to it is ABCD up on top. Bottom and top, opposites. Okay, we know that here we have perpendicular lines. It says two lines in the same plane either parallel or intersect at a point. We know that perpendicular lines form at 90 degrees. So here are postulates. Remember, postulates are things that you don't have to prove. So parallel postulate. This is the geometric definition of parallel lines. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Alright, now let's break that down a little bit. If there is a line, here's the line F. Here's another line. This thing says, if there is a line and a point not on the line, so here is line L. Here is a point. We'll call it point P. This point P is not on line L. Then there exists one line through that point parallel to the given line. In other words, there is exactly one line through point P that's parallel to L. So if we have any point, we can call it point Q. There is only one line through that point that is parallel. You can't have multiple lines through a point that's parallel. One and only one line goes through this point, and that one and only, well, many lines can go to this point, but one and only one line goes to that point that is parallel to L. Perpendicular postulate says the same thing. we have some point P. There exists one line through point P, exactly one line, that is perpendicular to the given point. Again, there's exactly another point. Call it point R. There exists only one line through that point that is perpendicular to the given line. Perpendicular postulate. I'll write it, if we use it in a proof, parallel postulate like that, or perpendicular. That's the symbol for perpendicular. Postulate like that. Okay. Not worried about that. You guys can tell that. Alright, some more definitions. We have here corresponding angles. And it says this. Two angles are corresponding angles if they have corresponding positions. So, we have... Actually, I'll do it here. We have these two, because these are good a line. We have these two lines. We have this third line that cuts across both of them. If you notice number 2 and number 6, they're called corresponding angles because they are in the same position. So think of it this way. Upper right hand corner, upper left hand corner, bottom left hand, bottom right hand. Same thing down here. Upper right hand, upper left hand, bottom left hand, bottom right hand. So if here the 2 occupies the upper right hand space, the 6 over here occupies the upper right hand space. So since they both occupy the same, not the same space, but the same positioning in space, upper right hand, they're corresponding. So these would be corresponding angles, 2 and 6. Then we have something called alternate interior angles. 4 and 5 would be considered alternate interior. We have these two lines. We have this line that cut across both of these, and it says two angles are alternate interior if they lie between the two lines of a plane on opposite sides of the transversal. We're using the word transversal? Have we Oh, I'm silly. So transversal is a line that intersects 2 or more coplanar lines at different points. So basically, we have 2 lines. The line that cut across both of these is called the transversal. So this is the transversal. And it doesn't have to be just 2 lines. As long as they're in the same plane, it could be 3 lines. It could be 4 lines. It could be infinitely many lines, as long as they are within the same plane. Transversal. Okay. Usually when they say transversal, they call it the line T for transversal. So we have our transversal. They lie between opposite sides. So this is the right hand side of the transversal. This is the left hand side of the transversal. It says if they lie between the 2 lines on opposite sides. So this guy is over here on the right, this guy is over here on the left, and they sort of look like a diagonally across from each other. This guy would be from the first set of 4 spaces, 1, 2, 3, 4. This would be the bottom right. This guy would be on the top left. So they would be in alternating positions. Right to left on different sides, left to right on different sides of the transversal. And it says interior because these guys are inside the 2 lines. So here's the line here, here's the line here. This is the interior between the 2 lines. Outside of the 2 lines, we're going to find the next one are called the exterior. inside the two lines, these are called interior, and they're on opposite sides. On the right, on the left. On the right, on the left. And they're always going to be in different positions. So this is right and left. This is bottom right, top left. And we have alternating exterior angles. They lie on the outside of the two lines. So here's the outside, here's the outside, and they're on opposite sides of the transversal. So this guy is up here. I would call this guy the top left. This guy would be the bottom right. Top left, bottom right. Outside and on opposite sides of the transversal. Remember, opposite sides of the transversal. This guy and this guy would be the same side of the transversal. This guy would be on opposite sides, but they have to be alternating, not in the same. Not in the same line, right? Both lines are different. The only thing that they're on the same side of is on the transversal, but on different lines. So this is on the outside on the top line. This is on the outside on the bottom line. And there again, you can almost draw like a diagonal line between the two. Alternating exterior angles. Then we have consecutive interior. They've also been called, so consecutive interior. They've also been called same side interior. They've also been called same side interior. Here we'll call them consecutive interior. They lie within the transversal and they're on the same side of the transversal. They lie within the transversal and they're on the same side of the transversal. So 3 and 5 would be consecutive interior. So, what type of angles are we dealing with? Here with number 3, these guys would be corresponding angles, right? They're in the same position. This would be the top left, this would be the top left, same consecutive. These guys would be alternating exterior. They're on different sides of the transversals, separated by the two lines, right? So first line, this guy here. Second line, cut by a transversal, opposite sides. So you would sort of flip it, slide it down here. Flip it, slide it down here. And that'd be alternating exterior. These guys will be alternating interior angles. You can flip it, slide it down here, opposite sides of the transversal. Alternating interior angles. Okay, so that's that section. Just a definition-rich section about what these things are. The math is pretty easy. You're just looking at lines. 3.2 are the postulates and theorems that come along with it, and the first postulate for this chapter, not the first one for this section, is a corresponding angles postulate. So corresponding angles postulate, that's kind of how I write it. And it says that if two pair of lines are cut by a transversal, then the pair of corresponding angles are congruent. So I'm not going to write this whole thing down, but I suggest that you do. If two parallel lines are cut by a transversal, then corresponding angles are congruent. So I'm just going to write here that corresponding angles are congruent. Corresponding angles are congruent. Since it's a postulate, we do not have to prove that. Isn't that neat? I think it's neat. Alright, so then we have a bunch of theorems. And remember, theorems are the ones that we have to prove. So the first theorem they give us is alternating interior angles theorem. So I write that AIA. Alternating interior angles theorem. And what alternating interior angle theorem say is that alternating interior angles are congruent. So if two parallel lines are cut by a transversal, then pairs of alternating interior angles are congruent. So alternating interior angles excuse me, are congruent. Alternating interior angles are congruent. Alright, these are all theorems. Then we have alternating exterior angles. Again, if two lines are cut by a transversal, then alternating exterior angles are congruent. Then we have consecutive interior angles. So consecutive interior, the CIA. And consecutive interior angles say that if two lines are cut by a transversal, then pairs of consecutive interior angles are supplementary. So consecutive interior angles are supplementary. I'm shorthanding it. I would recommend that you guys write down the full definition or of the theorems. Alright, so we can use this doing some math stuff. Here we have upper left, we have bottom right. These guys are not anything to each other. However, we have this 115, we have this 4. So I know that angle 4 is vertical angles with 115. So if this is 115 degrees and 4 is also 115 degrees, I know that 4 and x plus 5 are supplementary because they're consecutive interior. So I can say angle 4 plus x plus 5 equals 180, and then you can solve for x that way. They got x equals 60. Alright. So for number 1, they say measure of angle 1 is 105 degrees. It's kind of hard to see. Well, what they want? 4, 5, and 8. 1, 4, 5, 8. Okay. So they want 1, 4, 5, and 8, and they said this guy was how much again? 105 degrees. Alright, well, if 1 is 105, then 4 is 105 because they're vertical angles. 4 and 5 are same side alternate interior angles. So if this is 105, then 5 is 105, and then if 5 is 105, then 8 is 105 vertical angles. But you can also use alternating exterior. 1 and 8 can also be 105, and then 8 and 5 can be 105 too. Many ways to get there. This one says if 3 is 68, find 8. So angle 3 equals 68 degrees. Angle 8 equals 2x plus 4. Alright, let me check that out. So here's angle 3 right here. Here's angle 8. Well, couple of things. They're supplementary. And here's why. If I look at angle 3 and 4, they're linear pairs, right? So these guys are supplementary. And then angle 4 and angle 8 are also corresponding angles. So 4 and 8 are corresponding, and 4 is a linear pair with 8 and supplementary. Then 8 is also supplementary with 3. So I can say that 68 plus 2x plus 4 equals 180. That's how that works. Then I got 72 plus 2x equals 180. And I got 2x equals 108. X equals 54. And then to run a check, I plug that in. 2 times 54 plus 4, which is 108 plus 4, which is 112. And 112 plus 68 is 180, so it works. X is 54. Okay. Proving the alternate interior angles theorem. 4-step proof. We have angles 1, 3, and 2. 1, 2, and 3. We're given that P is parallel to Q. So we have to know this only works if parallel lines cut by a transversal. And they want me to prove that 1 is congruent to 2. Okay. This is where the corresponding angles postulate comes into play. First thing is you're given these are parallel lines. Then I can say that angle 1 and angle 3 are congruent because of the linear pair corresponding angles postulate, which says that corresponding angles are congruent. Then I can say that angle 3 and angle 2 are congruent because of vertical angles theorem. And then I can use the transitive property of congruency to say if 1 is congruent to 3, 3 is congruent to 2, then 1 is congruent to 2. Transitive property of congruence. That is the proof of alternate interior angles. Okay. And that's the section. Hope you have a great rest of your day.